Well, I've been talking a lot and on mute. So, okay. So, all right. So I was just saying that maybe we should start because our audience, they've been waiting for us for a long time. And we have a very interesting mix of pharmacy automation players, of retail pharmacies, of packaging automation players, also of medication packaging, because the case studies and the use cases that we are going to be discussing today are very, very relevant for this entire group, right? So a very warm welcome to our audience. Good morning, good evening, because you're joining us from all over the world, and a very warm welcome to our speakers. This is Finarb's session, and today we are discussing about how to enable more efficiency in pharmacies through AI and automation solutions. So we will be discussing how AI integrated pharmacy automation solutions has played or is playing a very crucial role in solving top concerns for pharmacies in aspects of accuracy in dispensing, in reducing any risk of errors, and thereby increasing efficiency and patient outcome. We'll also be discussing how robotic pharma dispensing solutions are enabling in increased medication adherence and better patient outcome through our use cases. And we'll also touch upon, which are the other areas of operational excellence in pharmacies that are being enabled by AI, right? So just a very quick, I'll just move to the next slide. Yeah, for those of you who are new to our session, I'll just spend a moment to introduce Finarb Analytics Consulting. We are a consult to operate advanced analytics AI/ML solutions organization, healthcare being a predominant vertical. We've worked with clients such as Teva Pharma, Parata, now part of BD, Frazier Healthcare Partners, CPS LLC, which is a leading pharmacy support solutions provider, Parkland Center for Clinical Innovation, among others. And moving on to our speakers and to our panel, would like to introduce Art Swanson. He was the former VP of Product Development for Parata Systems. He comes with 20 years of experience in health tech, having held similar roles in Optum and Allscripts. Next up, we have Anuj Chatterjee. He's Vice President of Data Science at Finarb Analytics Consulting. He has been working with Finarb for close to 5 years now, and prior to that, he has worked as a senior data strategist for ZS. And he's also worked with Wacker Chemi, where he was directly involved in the design and optimization of the production and supply chain processes. And we have Adam Docrat, who is heading IT at Aster Retail, which is one of the Aster Pharmacy, which is one of the leading retail pharmacy chains in UAE and the rest of Middle East, and also expanding in APAC. And he's held IT leadership positions at companies like Life Pharmacy and Masaki Water. So a warm welcome to our speakers, and thank you for making time for this session. Just a quick thing for our audience before we kickstart our session, that this session is being recorded. You will receive a recording at the end of the session, like sometime tomorrow actually. And also the audience is muted. We will have an audience Q&A at the end of the session. So please put in your questions in the audience chat board that you see on your console on the screen. And we will take your questions at the end. And also would be nice if you can direct the questions to the particular speaker, be it Art, Anuj, or Adam, and we'll respond to those. And if in the interest of time, we are not able to take up a few questions at the end, be rest assured that we will address those in an email afterwards. All right, so we kickstart with you, Art. So Art, you've been, of course, you've been the former VP of Product Development at Parata. You've led the product team at Parata and Finarb, who were working on, integrating deep learning AI in Parata's pharmacy automation solutions. Could you touch upon, how deep learning AI is actually enabling higher accuracy in various aspects of fill detection in pouches or in blister packs versus traditional machine vision models?
Sure. So if you want to advance to the next slide. So first of all, automated inspection systems in pharmacy automation have been around for almost 20 years. This is not a new technology. They've been well proven, well demonstrated in the market. Very successful products that have really addressed automated inspection at a great level. And these existing legacy products use what's called computer vision based approaches or feature extraction based approaches. And basically what that means is that they look at each pill and they try and identify its size, its shape, its color, its dimensions, any inscriptions on the surface of it, and then it matches those features against a database of features to see if it can match the right pill. Again, this has been very successful in the market, and it has about a 90% accuracy when you've got a well-trained database and a good system, which again is a very successful benchmark. However, at Parata, as our larger customers started to scale, what we came to realize was that the actual error rate of the pouch dispensers is about 1%. But the inspection systems would, because again they're about 90% accurate, they would flag about 10% of the pouches for pharmacist inspection, just to make sure that it's the right pills in those pouches. Again, 10% is a lot better than 100%, which was what it was previously. But as pharmacies started to scale, that 10% of pharmacist check time actually got to be a significant issue, right? When you're running hundreds of thousands of pouches, that's a lot of pharmacist time that's dedicated to checking pouches that for the most part are correct, because again, these machines have an error rate of about 1%. So most of that pharmacist inspection time was looking at pouches that were actually correct. And so that was an opportunity that we identified of, rather than using feature extraction, could we use deep learning, a deep learning approach that might be more accurate? And so when we did some initial testing on our systems at Parata, we were able to get, in our first pass, really about a 96% accuracy rate. And so that was enough for us to say, hey, we think that this is a great approach, and that we feel like we can get better and better than that 96% accuracy range in production. And that's why we decided to look and see if we could build out a deep learning model for pouch inspection. So if you can go on to the next slide. So again, I think the key thing to understand here is that feature extraction, this existing computer vision model, trying to match the size, the shape, the color of the pills in production, there's some significant challenges with that, right? So because, for example, the color of the pill, depending on the ambient lighting environment, the color can be rendered differently, right? And therefore it doesn't match the color of the pill. Same thing with shape and size of the pill is, in these pouches, obviously, very frequently you'll have overlapping pills, and that can make it difficult for the feature extraction based approach to successfully identify the shape of the pill or the size of the pill because they're overlapping. Moving to this deep learning model where we're doing pattern matching rather than feature extraction. So all we're doing is saying, hey, how similar is this piece of the pill that I can see to all the other pills that I've seen before? And you're doing a similarity match. And so that's a lot more noise tolerant to different environmental factors like lighting or stacking of pills or rotation of pills or those things. And so that model gives us a much more robust solution, we think, for improving the accuracy of inspection. But the other thing that's important about that is, again, these existing computer vision models really rely on each individual customer to train those, the pills that they use in their pharmacy locally on each individual machine. And so what we saw at scale again at Parata is that how well they trained those machines had a big impact on its actual accuracy rate. And then, one of the big challenges we saw was that you could actually have different performance between two machines within the same pharmacy, just based on how those models were trained locally. And so that difference in performance makes it challenging to, really optimize your operations over time. And so this deep learning model also allows us to have a generalizable model that we can deploy across all of our customers and that can be deployed out of the box so that customers don't need to do that local training of all the pills that they had. So how does this net out in terms of actual value for customers? That delta, right, of moving between a 90% accuracy rate and a 96% accuracy rate really can have a significant impact on pharmacist inspection hours. And so you can see down there at the bottom that, if you're running 10,000 pouches a day, you could save an hour and a half of pharmacist time per day. And as that scales up, that number can get very, very large. And it's not just the cost savings, right, of not having to pay that pharmacist for the hour and a half, but it's all the other things, all the other work, all the other value that pharmacist could be providing that they're not, because they're spending an hour and a half in inspecting those pouches. Additionally, we all know that retaining and attracting pharmacists is getting more and more difficult. And if you can remove some of the overhead and legwork of manual inspection of pouches from their from their daily work, that makes it a lot easier to retain and recruit your talent. All right. So the last point I'll emphasize is, it's this bullet point. It's kind of small at the bottom, but I actually think it's really important to call out, which was, so one of the one of the challenges that we had when we were working through a proof of concept of this approach was, we want to take pictures of the pouches, potentially send that data up to the cloud, so that we can do some training on that data. But being very careful with PHI was a main criteria for us. And so the Finarb team did a great job of building an algorithm that can automatically remove the PHI from any image locally. So before it leaves the pharmacy walls, it removes that PHI, and so that the image that comes back up to the cloud is scrubbed of any possible PHI or PII, and it's just the images of the pills themselves that we need to use for training. So I think it's another example of how you can use AI to solve problems. In this case, it was a security problem or a privacy problem. We wanted to make sure that we weren't sending any PHI or PII up to the cloud. All right, Aditi, I think you can go to the next slide. So moving on to blister packaging. So blister was really interesting because some similar problems, but some different problems. And the primary problems in the blister space is broken pills and double pills. And so Parata, purchased SynMed, which is a blister packaging company. For those of you that aren't familiar, SynMed has a pick and place automation model where they've got basically vacuum powered tubes that will dip into a container of pills and kind of suck to attract a pill to the end of the vacuum tube, and then it'll pull that pill up. And so the challenges on the SynMed side were, as those tubes go down into that container of pills, they can break pills, right? And sometimes a broken pill gets pulled when you pull that tube up. So they're looking for broken pills. And the second thing is, because it's using vacuum power, sometimes two pills can get attached to the end of one of these these tubes rather than just one pill. And so just making sure that there are no broken pills or no double pills when we're doing pick and place blister packaging was the challenge. And again, the teams have been trying to use computer vision based approaches for multiple years with limited success, around an 80% accuracy range. And we ran a proof of concept with a deep learning algorithm to detect broken pills and double pills, and again got that accuracy rate up above 95%. And really the two challenges in the blister space, with broken pills is as I came to learn, broken pills can be like a very small chip, right? But that's still a defect, and they want to flag that. And so having an accurate enough algorithm that can detect a slight chip in the surface of one of these pills as the pills are rotated through 360 degrees, because remember, it's kind of picking a pill at random from a pile of pills, and so that pill can be at very different angles. So that was one challenge that the team, I think, did a great job of overcoming. And the second one with double pills, similar to our pouch model, where those double pills can be overlapped depending on where the camera is looking at the end of the pipette from. And so making sure that the algorithm was able to detect even slight differences in concavity that would show that there's a second pill behind that. That was another challenge that the deep learning model, I think, was really successful at. All right, and so I think from a pharmacy automation perspective, those were the two kind of today use cases that we had when I was at Parata. If you go to the next one, I'd like to talk a little bit about maybe the future use case. So as we kind of demonstrated proof of concept with both, pouch inspection and blister inspection, I think it certainly opened everyone's eyes about the opportunity for a more generalized quality control approach using vision. And so very common across manufacturing, in lots of industries, is to use, vision systems to perform quality control, catch defects as early in the process as possible so that you limit your downstream impact. And in pharmacy automation, I think one of the big opportunities is, catching those pouch defects as soon as we can after they're dispensed. Because when a machine dispenses a batch of pouches, it's a big roll of these pouches, and then we do the inspection, and then we'll find the one pouch in the 400 pouches on that roll that needs to be fixed, and we've got to fix that pouch at that point. Another thing that can happen, in pouch dispensing is that you have cascading errors. So like if one pill is supposed to drop in a pouch, but it drops in the next pouch, then every other pouch after that can be in a defect state. So if you can catch those errors very quickly and stop the batch rather than processing the whole batch, there's huge value there. And so, obviously putting an inspection system on the output of the pouch packager, looking for pill count, label issues, those kinds of things, and being able to potentially stop the packager right at that point so you don't, cascade those errors downstream, we think is one example of that more generalized vision QA approach. All right, I think that's what I wanted to cover, Aditi.
Thanks for that, Art. And in fact, it's quite interesting what you said, that it's about a vision-enabled detection, not just after dispensing, but during the workflow to prevent any cascading errors. And I think that's going to be extremely valuable for our audience, which I said is already a mix of not just pharmacy automation or pharmacies, but also packaging automation and medication automation players.
Yep.
So thanks again, and that's a very nice bridge to our next session. And I move to Anuj Chatterjee, who is VP Data Science at Finarb. So we've seen what Art mentioned was about accuracy in pill detection, right? And now we are moving to building further accuracy in dispensing. And large pharmacy chains, of course, they often deal with very high volume of prescriptions per day, and then add to that the complexity of different medications, different dosages, and the traditional approach is, of course, like a manual check by the pharmacist to check the prescription and assign them to the dispensing machines. So could you tell us, Anuj, more about Finarb's use case on AI-enabled prescription routing system, which optimizes this workflow and enhances efficiency?
Sure. So first of all, thank you, Aditi, and thanks, Art, for this wonderful overview of the stuff that we did together. It was actually a great experience. I just want to start. It was a great experience working with you personally, and sharing all the business context. I got to learn a lot about the market from you, to be honest, because and right now we've been working with Parata like close to 4.5 years now. So yeah, I've been in the market for 4 years, sort of having worked with them. You come across a lot of bottlenecks that are there in the entire sort of value chain when you when the going from a prescription to generating the prescriptions, routing into the machines, they're getting out those bottles, then finally sending them to the patients in time, and ensuring that adherence packaging is ensured, and all of those things. So yeah, just great experience working with Parata on this. And just on that lines, once a prescription comes to the pharmacy, it's extremely important for them to, given that they have this huge load and there's a very high requirement for them to get the prescriptions out on time, because sometimes they are for urgent medication, sometimes the diseases that they're treating are very severe diseases sometimes. So the timely dispensing of drugs is of paramount importance. Now, if we consider a very small situation here, which is represented in the diagram, uh, so there are, say, 3 prescriptions, and each prescription, the first one has 9 types of medication, the second one 6, and the third one 4. And then you have all of these dispensing machines, which is machine 1, 2, and 3. And then you see that they have their own setup times, they have their own processing times, and they have their own operational costs. Then there comes the complexity of some medications going into some machines. I mean, all based on the size of the pill, based on other factors, there are constraints on what medication can be dispensed by what machine. So even in this situation where there are just 3 prescriptions, these types of drugs, and there are 3 machines in the pharmacy, you understand that the complexity is pretty huge. When somebody has to do this manually and make sure that none of the machines sit idle, make sure that the make span and the collation delays are sort of reduced. Just for uh, some background, make span refers to the total time in between delivering all the prescriptions on that day versus maybe a collation delay, which is the delay between the first drug of a prescription and the last drug of that prescription. So given that we have to think about all of these multiple objectives, it's very difficult for a human person, even with their amount of knowledge and experience, to sort of do this very efficiently. Uh, Now consider the real life scenario, which we talk about on the right side. I mean, a standard US pharmacy sort of receives more than 10,000 prescriptions, each prescription having different medications, different dosage forms, different sizes, different sort of urgency needs. The cost of operating the machines is also different. And also as I said before, the medications going into certain machines what will not go into other machines. So that complexity is also there. So again, I mean, we thought, this is not a solution that is, I mean, in terms of the use case, probably it's not novel, but the way we tried to solve it, we tried to use, state-of-the-art machine learning or optimization algorithms to get this done. A big problem in this is actually the multiple objective that I was talking about. So you have, at the same time, you have to reduce idle time or wait time of the machine, and also you have to optimize or increase the the throughput of the machine. So sometimes these objectives, when we do sort of an optimization problem, the objectives might be feeding off of each other. What I mean to say is that when you sort of tweak your parameter set and you bump up one of the objectives, the other objective might go down for that parameter set. So this sort of a multi-objective optimization problem is more complicated to solve than general, maybe linear constraint optimization. Yeah, if we can move to the next slide, Aditi. Yeah, so now how AI does this. So AI, I mean, the first step obviously is to collect the data from the various sources, right? You have your prescription orders, and all of this is historical data. You have your prescription orders and what are the medication characteristics, and other features regarding the drug, as I was talking about, the sizes and other things. And the biggest challenge in this problem is actually setting up the constraints of the pharmacy. Now, I mean, in terms of constraints, you can understand that it differs from pharmacy to pharmacy and also from machine to machine. Now, this setting up the constraints and finally converting this business problem and forming a mathematical problem out of it is the challenge. So as you can see, I mean, some of the benefits that are coming out of this are, faster prescription fulfillment, cost reduction, enhanced resource utilization, and improved customer service. So the ultimate aim obviously is to make the medication available to patients when they want it, and any sort of delay in dispensing sort of creates, again, I mean, using arts terms, it sort of creates a cascading of errors and cascading of delays, and that just sort of you know creates further delays in getting the medication to the patients on time. So on the right, we just have a few of the parameters that are used to understand the differentiating factors in an AI-based solution versus a traditional manual workflow. Sorting and assignment workflow, these are extremely it's very difficult to control the workflow and proper sorting when a human is doing it, because as we said, I mean, the load is huge and it's not possible for a single human to control it. So the workflow becomes much more dynamic. We can reduce the idle time of machines to a large extent, and also again, finally, the customer satisfaction is high because they're getting the medication on time. A little technical detail that I wanted to get into is that we sort of did a Pareto-based min-max approach in solving this problem, which is a very accepted algorithm used to solve such optimization problems which have multiple objectives. So there are some famous algorithms like the multi-objective genetic algorithms, the non-dominated sorting algorithms. So what these do and how this is different is that these algorithms sort of give you the result sets that are non-dominated. What do I mean by non-dominated? These give you the results that the set of parameters that will not hamper the second objective if they boost the first objective. Okay, so if there are 2-3 objectives, it sort of creates a frontier for the business to actually decide, okay, which objective should I give more weightage on. So that's the basic differentiator in this type of an algorithm, where you're not optimizing for one objective, maybe multiple objectives, to give that sort of control to the business, and based on their situation, based on the pharmacist situation, they can tweak the algorithm to sort of give importance to one objective versus the other. So in short, it's extremely important for any pharmacy that does large scale ordering or has a lot of prescriptions coming in, to have some sort of an optimized automated dispensing method in place. Coming to the following use case, how it ties back to this use case is, so all of this optimization and the constraints that we bring in is based on an ideal scenario. In an ideal scenario where there are no breakdowns, where there are no there are no situations where a machine is not available for dispensing, and we have considered in the algorithm that it will be available for dispensing. So a very important part to solving this bigger puzzle is actually being able to do predictive maintenance with great accuracy as well. So again, I mean, there are two parts of predictive maintenance that we have solved. Broadly speaking, one is the remaining useful life of the machine. Now, this sort of talks about the survival, the age of the machine. So when a machine is set out in a pharmacy and it starts sort of dispensing drugs, based on a lot of based on the machine itself, its characteristics, and based on a lot of local factors like the temperature of the site, the amount of load the machine carries every day, the number of pills it's dispensing every day, a lot of local factors also sort of contribute to the degradation of this machine over time. Now, if we are able to predict for a machine that, okay, this machine is going to last you for another 2 years, or this machine is going to last you for another 5 years or 1 year, so that sort of helps the machine manufacturers, in this case maybe Parata, to sort of do their manufacturing planning in a much more efficient way. So if they know that 3-4 machines out in the field are going to be they have to be deinstalled in the next year or in the next 2 years, they would have to do that manufacturing planning in-house to account for that change, because the demand doesn't go down, right? They have to match the demand with the supply of machines, so they would have to replace those machines as soon as the machines have to be deinstalled, the existing machines have to be deinstalled. So that is something where RUL becomes extremely useful, and it also actually gives you another insight. So say you make a prediction of a machine standing on a point of time, and you say that the machine is going to last you for 2 years, and then say 6 months later you probably regenerate this prediction and you see that now it has become 6 months. So maybe the actual prediction, which is 2 years, has gone down to 1 year. And this can be because in these 6 months there was exceptional load on the machine, or maybe the weather conditions in that area changed, or the conditions in which the machine was being operated changed. So we can also understand how each machine's RUL sort of changes over time. And again, this is something that needs to be accounted when production planning is done on the manufacturer's side. The other interesting piece to predictive maintenance is actually the prevention of breakdown maintenance. And Aditi, if you could just, yeah, thanks. So the prevention of breakdown maintenance is essential because, again, I mean, as I said, the routing, the dispensing depends on the machines being active throughout the day, or the time of the day that the pharmacy is open, or they are dispensing drugs. So knowing which machines will sort of have an error that is okay. Sometimes errors are not big enough for the production to stop. They are in terms of warnings or something, but sometimes the errors are, they are such that the machines stop working and there's no way you can continue dispensing. And sometimes these machines, since they are routed through I mean, they are connected through this centralized routing algorithm. One machine stopping to work might, screw up the entire algorithm in itself. So accurately predicting which machines will have a high probability of having an error in maybe the next week or the next month or the next 2-3 days, the timeline sort of dynamic, and accordingly the data set has to be made, is essential. We have a lot of data. Actually, most of these machines have sensors fit in them, so we have a lot of data coming in to the sensors, through these sensors to us. I mean, uh, points like temperature, pressure, other things about, there might be dirt on in some of the vials, stuff like that. So a lot of sensor data comes to us through the machines. And one of the challenging pieces is actually to extract this data through some sort of a streaming service, and accumulate this data, and use this against the historical errors that you have seen. So we would also have a data where we would be capturing which, okay, this machine had this error at this point of time. So combining these two data sets, sort of, you can create a modeling data set and understand that, okay, based on the characteristics of the machine that we're seeing in the current week, what are the chances, or what is the probability that this machine is going to have an error in the next week. Further extending this use case is exactly what error would happen. Now, how does this help? This helps in, if we can accurately predict the error or the type of error that will happen on the machine, we can also predict the parts that would be used. A lot of a lot of times field service engineers would go out on site with their kit bag, which has their trunk parts, and sometimes some non-trunk parts might be required, which again would cause a delay of 2 days, where the parts are shipped overnight and they would stay at the site doing nothing. So the requirement of parts is also very important. Predicting that is also very important. And we need to, once the parts are once the parts are predicted, the other important thing is, now since you have an understanding, okay, next week I'm going to have these machines that are going to have some errors, or have a probability of having an error, and these machines have lower probability of having errors, you can accordingly plan your resources. I mean, by resources I mean your engineers, that okay, this area or the central region has more machines that might be facing errors, so I'll probably put more stress on keeping my resources focused on the central region. So all in all, it's a very important thing for pharmacies to understand when their machines would fail and when their machines could break down, for them to sort of streamline the entire process of servicing the pharmacies as well. Lastly, I'll just briefly touch on a use case, and I'll not take more than 2 minutes. I know I've been speaking for a long time, so I'll just briefly touch on a use case which is not related to pharmacy automation, but it talks about a very important thing, which is extending the tracking of adherence of medication of patients. Now, as Art was saying, one of the first things that we do is actually check the pouch if it has all the medication that it is required to have in the right quantities it is required to have. But that is not everything, because you cannot do real-time or accurate patient monitoring of patient adherence through that. All you know is that, okay, the right pills have been sent to the patient, but we don't know whether the patient took the pills on time or whether the patient actually took the pills. A lot of support organizations have and we've actually worked on with one such support organization which sort of collects a lot of data from the patients in form of surveys, and there you would get a lot of data about a lot of real world data actually about what the patients are feeling, some adverse effects, how much pain are they feeling, are they taking their medications on time. And based on all of these data sources, we can combine this real world data with your prescription refill data to generate recommendation of actionable interventions that might help the patients actually adhere to the medication. Sometimes it might be a knowledge gap, sometimes it might be they're just not aware of how adherence helps, or how important it is to be adherent to a medication. Sometimes it might be something else, sometimes it might be features regarding the drug that they are having side effects so they can't take that. So all of this helps in generating actionable item or recommendations that we can help to increase adherence. And lastly, if there are medication dispensing robots that are dispensing medication at home to the patients, then you actually know at what time the medication has been taken, and it can be used to actually track real time whether the medication was being taken on time. These sort of solutions are generally backed up by a mobile app or something where you have the opportunity to enter your dosage, you have the opportunity to track your dosage, you have the opportunity to share if you have missed a medication with somebody, you can set reminders, stuff like that. So all in all, I think pharmacies play a huge role in in ensuring that medication adherence is preserved in patients, and it's one of the biggest challenges in the US right now, making patients adherent to medication, especially patients who are a little older. And so I think all of these use cases combined would help pharmacies serve patients better. So yeah, that was my 2 cents.
Well, thank you so much, Anuj. And you rightly said that all of these solutions are actually helping transform pharmacies from, what it was like a medication dispensing, shop to really a patient support organization, enabling more and more better patient outcome. And, the use cases that you shared are also interesting because you said that the success of the routing or the dispensing solution, it actually would depend on how well your machines are running, and therefore tying in the predictive maintenance part of it. Because often when we see about deploying AI solutions or AI use cases, companies tend to just deploy one AI use case to see the benefit of it. I understand that they want to start small, but it's also important to understand the interconnectedness of processes and of workflows, and do you have efficiency built in every of those processes to be able to see the full value. So that was a great narrative. Thank you so much. So we'll move to Adam. Hi, Adam. So you are heading IT at Aster Pharmacy, which is of course one of the largest pharmacy chains in Middle East and APAC as well. In our last two sessions, we saw more of how AI is enabling pharmacies, in dispensing accuracy, in error detection, more from a US perspective. What do you see in the Middle East? Is there anything different that's happening in the GCC area? And also another point is that the whole of this dispensing, seamless dispensing, relies a lot on inventory as well, right? And Aster has implemented inventory AI. So if you could touch upon that as well, and what are the benefits you're seeing from there?
Sure, thanks, Aditi. And it was great to hear from both Art and Anuj. I love the bit about patient adherence and using mobile apps to drive that patient adherence. I think it's a really great point. So, just to start off with, here in the GCC, I think it's very different to how pharmacies operate in the US. We don't have individual packs or pills, I should say. All of our dispensing is done on boxes. It's done predominantly directed from the doctor and pushed in. So, in terms of, what we term as pharmacy automation, a lot of what we term as pharmacy automation is, how we can automate the entire patient process journey. Here in the UAE specifically, and in the GCC, we have pretty close to 100% insurance adherence, which is obviously very different to the likes of India and the US. And a lot of the direction in terms of what the patient is taking is directly coming from the doctor. And one of the automations, I should say, not necessarily AI, but automations, is talking around the speed to dispense. And how we do that is the second the patient finishes at the doctor, we're trying to pick up and capture that prescription information and direct it directly down to the pharmacy, get it into the pharmacy, and not just leave it there. We're going to take the initiative from a system perspective to send it for the approvals automatically, let the insurance approvals, let all the back-end processes happen, let it get directed down to the person in the pharmacy, let them pick, pack, and get the medicine ready, so that by the time the customer has walked in to the pharmacy after they've paid and they've gone downstairs to the pharmacy, the bag is ready for them. Anuj and Art touched upon patient patient happiness, I should say, and the reduced waiting time is probably the key to all of this. You're sick, you're not well, all you want to do is feel better. And by putting all these automations in, by putting all these integrations in between ourselves and the doctor's clinics, it really just speeds up the patient journey to make sure that once the patient gets there, they're spending the shortest amount of time to get there. Even in regards to things like dispensing accuracy, we have now recently implemented Tatmin, which is a local solution which is brought in here to serialize every single piece of medicine in the country. So every box of medicine now in the country is completely uniquely serialized. And what that has done is that has allowed us to make sure we are always giving the right medicine to the customer. So when the pharmacist scans the product, it immediately ties it to the prescription. It immediately makes sure that that is the exact item and the exact strength, and everything 100% accurate down to the customer. And obviously that not just make sure that the customer is getting the right product, it's making sure that they're more likely to obviously take the medicine and then take it in a more accurate way. So, in terms of the challenges that we're currently seeing here in the UAE, I know Anuj touched upon patient adherence to taking medicine, but a lot of the challenges we're seeing here is a lack of automation. It's a lack of AI. It's a lack of predictive analysis, and not just around pharmacy products, it's around the supplementary products that come with it. Because you get prescribed an antibiotic, for example, the natural inkling is to get prescribed a probiotic, and we want to make sure that patients get those supplementary procedures, because the aim isn't to fix a sick patient. The aim is to start that journey from illness to wellness. And I think that's been our motto over the last year, is really drive that journey from illness to wellness. And how can we take a sick patient and not just make them feel better, but make them feel well, and really just enhance that patient's life cycle. So a lot of the automations we've started to put in are things like pause nudges to the pharmacy to upsell them on specific items which are unique to the patient, nudging the patient when it's time to take their medicine. So getting that data from the prescription and saying, right, you've used your 30 days, we know you need another prescription, here's your reminder to go and get a prescription, so they can continue on their wellness journey, and then start pushing them products and supplements and items which will just help them overall on their wellness journey. So if we go to the next slide for me, I just want to talk, very quickly around inventory and inventory automation. I think, making sure that you have the right product in the pharmacy. There's nothing worse than a patient getting prescribed an item, going into a pharmacy and not having the right product available for them, whether that's the brand or whether that's a generic, making sure all of those products are there. So we've put in really state-of-the-art level solutions. The solution is actually called Slim Stock. And what it does, it analyzes absolutely everything across our entire ecosystem, making sure that all of our products, all of our items are stocked in the right pharmacy at the right time and at the right quantity. Because whilst it's great to say, let's just dump as much stock as you want to in a pharmacy, you've obviously got to be concerned about things like cash flow, things like making sure those medicines don't expire, and making sure that you physically have enough space to keep those products. So using AI, using ML, and constantly updating that data as patients change, as seasons change, as your flu season comes in, as all of the little pieces around inventory sort of take place, making sure that those orders are going to the right suppliers, making sure all those products are coming back in, and also making sure that you have things like inter-branch transfers. Now, we're a network of over 250 pharmacies, and it might always be that one pharmacy is overstocked with an item, one pharmacy is understocked with an item, and allowing the system to be intelligent enough to say, let's take those items from the slow-moving pharmacies, let's move them into the fast-moving pharmacies, not just to protect the expiry and make sure that that item doesn't get expired, but to make sure we have an accurate allocation of stock across the business. It might be that, a pharmacy has accidentally ordered a particular item, and now that item is out of stock in the market. Instead of leaving it in one location, we can now distribute it to a whole bunch of locations, making it more accessible for all of our patients. Things like promotion management, making sure that when items, and maybe less so for pharma, but more so for non-pharma products, but again, your supplements, your vitamin C's, your D's, your multis, making sure that when those go on promotion, we accurately raise the levels to a correct level to deal with those promotions. But then when the promotion finishes, make sure we don't keep reordering at the promotion level, making sure all those stocks bring themselves right the way back down to the optimal level so that the patients have enough stock, but also you're not overstocking your pharmacy. And then the biggest thing, and I think I'm not sure how much it is in the US, but it's a real big problem here in the GCC, where medicines are predominantly kept by one supplier. We don't have a multi-supplier concept here, and it can be that certain products go out of stock. I don't know if you've had this in the US, but specifically here in the UAE, we've had Mounjaro and Ozempic, which has been hugely, sales have just been through the roof, since it came up as a weight loss drug. And what we've had to do is bring all that stock in, and there's been a lot of times when that stock is now not available. Now, if we start looking at sales history and saying you've sold 100, so now your mean is 100 per month, that's not the right methodology to use. You need to look at times where you had the correct stock levels in order to calculate your average. So removing those days where you didn't have stock on hand, removing the days where you didn't get that stock in from the supplier, and then building your average to a level where can get sold to the customer. So I think inventory management and then the AI and ML around that are really, really big parts of making sure that not just the accuracy of the product is there, but the right product is there in the pharmacy at the right time, making sure that, like I said earlier, we have those serializations, we have the batch tracking, we have all of the pieces interconnected together, ultimately, making sure that the patient has the ability to get that product whenever they need it, and in whichever location they need to get it to. If we could just move over to the next slide, then one piece again around that is making sure that transportation is a big part of it, and making sure that the products actually reach the pharmacy. Now, it's pretty easy to say, let's just create a list of items to order, put it on a truck, deliver it to the pharmacy. But a couple of things happen here. Firstly, in terms of route planning and using AI to plan routes, not just on where the truck is going, but looking at things like time of day, looking at things like real-time traffic updates to say that if I'm moving goods, and okay, in this region it's from Dubai up to Abu Dhabi, which is a good 2-hour drive, making sure I'm sending the truck in the shortest possible route, avoiding accidents, avoiding high peak traffic times, making sure that the truck can move as easily as possible. That also goes with making sure your vehicle also helps with the vehicle optimization. It also helps with our sustainability drive and making sure that from a sustainability perspective, we're using the least amount of carbon to get those products to the pharmacy. You know, a quick example is moving away from maybe daily deliveries, moving to twice a week deliveries or 3 times a week deliveries. You're reducing your trucks, you're reducing the amount of items you're actually putting on the trucks. And a lot of times what you find is you've got half full bins. So you might have a truck that's full, but actually there's enough extra space to put additional items on there. And then using AI to say, well, you know what, maybe my average stock holding period is 10 days, but if I increase it to 15 days, so I'm not burning cash and I'm not sort of ramping up my stock to 6 months, but saying that let's just increase it slightly. Maybe we can fill that truck up even greater. Filling the truck up gets more products to the pharmacies. It means that I'm replenishing the pharmacies less, and it makes sure I'm making less trips to the pharmacies. And ultimately, helping my sustainability, helping my vehicle optimization, helping my carbon footprint, and helping my delivery schedules, because it means that any emergency delivery I have, now I have vehicles available on extra days to make those emergency deliveries to the pharmacies. So I think route planning and specific AI around route planning is really important this day and age. And like I said earlier, with sustainability and the UAE hosting COP28 as well, I think a lot of people would have seen all the pictures of all the delegates and dignitaries who are here in the UAE driving that sustainability challenge. How can we play a part in that? And how can we also not just play a part in it by saying, let's cut electricity, let's cut deliveries? No, how can we do it in a way which both benefits the environment but also benefits the business, right? So keeping that top line high, keeping the costs low, but at the same time benefiting the environment. And then just to touch and just to conclude, I think the future around AI and automation, it's growing. I think what Art and Anuj touched on in terms of robotics. Are we there yet here in the UAE? Probably not. I think it's going to take a long way for that to sort of be really adopted. Once obviously the cost comes down, we have very specific challenges here in the UAE. I believe in the US, your pharmacies are quite spread apart. So in a locational area, you maybe have 1 or 2 pharmacies. Come to the UAE, and on a single road, you might have 15, 20, 30 pharmacies all lined up in a row. And that's for a number of reasons. It's the open market that we have here. It's the heat as well, where people want to travel less distance to get to a pharmacy to pick up stuff. So, the income generated from a specific pharmacy is significantly lower. So how do we use AI to drive down that cost of ownership? How do we use robotics? Maybe we don't have a fully fledged robotic unit, but maybe we take some parts of that. Maybe we just take dispensing chutes. Maybe we just take smaller parts of these automations and build them into lower cost solutions. And then I think that's the way we're going to drive physical automation. In terms of AI, I think predictive analysis is going to be the next big thing. Customers coming in and coming through with their symptoms and their problems, and AI really driving the customer to the right medicine. And Anuj, like you said earlier, using those medicine reminders, using those robots at home, using all of those tools and all that AI to say, are these patients actually taking their medicine? Are they following the right schedule? Because that's going to be the things that keep them out of our pharmacy. Ultimately, we don't really want them in the pharmacy. We want them out of the pharmacy. We want people well. We want people healthy. And I think that's the main drive for this.
You really wrapped it up well. How you said that we want them out of the pharmacies, we want them well. So that's great. Thank you so much, Adam. We are just in time to take a few audience questions. I'll stop sharing my screen. And okay, yes. So this is a question for Art. Well, it's a long one. I'll read it out. Although accuracy is very important, I would be interested if you can say anything about the false positives of the model.
Yeah, so false positives are where you think that the pill is correct, but it's not, and that obviously that's the that's the floor of any model. Is you have to make sure that if you're calling that the pouch is correct, you have to have a very high confidence level that that pouch is actually correct. And so you'll always bias on the other side and making sure that if there's any concern, if there's any doubt in the system's mind, that you flag that for pharmacists review. And so, never sacrificing that level while trying to reduce our false negatives, which is where the system flags that the pouch is incorrect when it actually is correct. You have to hold tight to that false positive criteria first. Absolutely.
Okay. Thanks, Art. We have a question for Anuj. Does the time series error network have the ability to discern between different errors, or can it only tell the chance of a general error which needs maintenance and when it's occurring? You are on mute, Anuj.
Okay, am I audible now?
Yes.
Okay. So as I was talking before also, the first step obviously to solving this problem is to predict that an error will happen. And the next step is from the historical data, since we know from our errors, historical errors, what sort of errors happened. So we also can predict with accuracy what error will actually happen on the machine. So it is possible for us to predict the occurrence of an error as well as classify the errors to the actual problem that the machine might have. So yeah.
So actually, I'll add to that, Anuj, because one of the challenges that we've had though in doing that error prediction model is that if the errors in the historical data are not categorized correctly or at a detailed level, then your model won't perform appropriately, right? And so as people are thinking about implementing these predictive models for error prediction, you have to make sure that your historical data in capturing actual errors and that it's granular enough to drive that model in the right way. So it's a highlight for people that want to do that. Is you have to make sure that your historical data is tagged in an accurate way and in a detailed way. Otherwise, the model won't perform.
Absolutely. I mean, annotations, I think, are the biggest challenge, the most time-consuming part. And any ML algorithm is useless if the data is incorrect, as Art is talking about. So, a very detailed exploratory data analysis and close brainstorming sessions with the stakeholders is absolutely essential to first curate the data that's required to building this model. And again, if the data is bad, the model is bad. So yeah.
Okay. The next question is again for the first case study, Parata and Finarb case study, which Art discussed. The question is for both Art and Anuj. So maybe Art, you can answer and Anuj can add on. Another question, how does the model generalize to non-NDC medicines? How do you incorporate medicines which are new? Do you need extra data from this medication to make it work?
Yeah, so the model generalizes to any pill in any form. It doesn't have to be an NDC necessarily. Obviously, that we need to be able to train those pills. I do think that the question is asking a little bit, and this was one of the interesting areas that we explored. And Anuj, I'll get you to kind of dig into that a little bit. But because there are new NDCs, new pills, new vitamins that are released on the market every day, how do you maintain that model and consistently add new data to that model? I think it was one of the significant portions of research that we did. Anuj, do you want to touch on that a little bit?
Yeah. So talking on similar lines, I mean, we are the models that we used have the sort of incremental learning capacity. So once new pills that are unrecognized by the model, they are automatically sort of when all of the what the model gives you is, okay, what is the probability that this pill is of this class? By this class, I mean this specific NDC. So when we see that it's a new pill, it'll say that probability of all the existing classes that the model know model knows is sort of low, and then that automatically goes into an annotation pipeline that goes into the training pipeline, and then the model is sort of incrementally trained on these new pills, and then they can be also this updated model is sort of pushed to production, and then the new pills can also be identified.
Okay. We have a question for Adam. In what ways does AI contribute to dynamic inventory optimization? In the sense, how does it adapt to changing market conditions?
So, it's a good question. So we run an optimization on a daily basis. So we recalculate our thing on a daily basis. We also look at the last 36 months of history. So as market conditions change, we'll see sales increase, and we'll naturally forecast accordingly. We also, look at seasonality and historical trends. But what we've also started to do is tie in with other suppliers. So there's a company out there here in the UAE who's now providing anonymized data of not just ourselves, but other pharmacy players and other supermarkets in the region to really feed us in that market data, and then using that market data and using AI to sort of say that, if certain products are being bought, this is the market trends that we're seeing, and then using it to update our AI models.
All right. Thanks, Adam. We have just time for just one last question, even though we have passed the 60 minutes. What is the biggest difference between AI and automation in pharmacy machines? Because when we talk about AI, we accept that the machine can decide by itself. Well, it's a general question. I think any one of you can answer that. So, I mean, I leave it to you.
So I'll take a shot because I want to follow up on some of Adam's thoughts, because I thought they were brilliant about sustainability and tying that back into what Anuj talked about, which is really multivariate optimization. I think at its core, when all of us talk about AI, we're really talking about that multivariate optimization, because humans are very good at optimizing one variable or a linear variable, right? We can understand that, we can predict that, we can tune that. But when you're doing trade-offs, especially multi-dimensional trade-offs, where the relationships are very, very complex, I think that's where AI really, really shines, is it allows organizations to really understand and model and tune their systems for these trade-offs, because that's the reality of the world that we live in. Is we've got lots and lots of data and lots of priorities, goals that we're trying to accomplish as a business, and how do we balance all of those things? It's almost impossible for a human to do, but this is an area in which AI is uniquely capable.
Great, that's great, and I think it's kind of the wrap up of the session, and the whole essence of the session. So thanks a lot to our speakers. We have come to the end of our session, and great questions from the audience. There are a few more which we could address, but we'll get back to you over an email. And like I said in the beginning, this session was recorded, and you will receive a recording of this session and our slides sometime tomorrow, along with our case study. So, well, thank you to our audience for joining, and thanks a lot to our speakers for making time. We end this session, and well, have a great evening ahead. Thank you.
Thank you, everyone.
Thanks.